My name is Hasit, Kilo Echo 8, Tango Juliet Echo. I wanted to do a small video demonstrating the capabilities we have with the G5500, the SAT rotator, and how we have set up so that you guys can use it. So I'll go through a small overview of what we have and how the current setup is looking like. Here you can see a picture of the rotator we have. During its testing phase, we have it located on the lower roof. You can see we have two Yagis, one a VHF Yagi and a UHF Yagi connected to the rotator setup here. And in this tutorial or sort of the demonstration, what I'm going to try to do is to use the rotator with an open source controller called the K3NG. You don't need to know a whole lot about it. It's properly calibrated and configured for our rotator. And that is going to be what we are interfacing with today. And also we'll have a ICOM 9100 connected to my computer so that I can do the tracking and do the Doppler shifting for the specific satellites. Now, in this video, I wanted to go through one of the apps. Gpredict is a app that is available for both Windows, Linux, and it also runs on Mac. So for today's setup, I'm on a Linux computer, and we're going to try to see how we can track and rotate the antennas using that setup. Now, before going on, just to explain a little bit about our setup further. So as I mentioned, we have a rotator, the G5500, and that is connected to a separate Raspberry Pi, which is on our network. And you can see the IP here. And this is dedicatedly for the SatNogs platform, and it's running SatNogs when it's not in use. Now, in case we are going to need to use it to talk to a satellite or do anything amateur radio, what we are going to do is we are going to temporarily disable SatNogs and then use a second computer to connect to the rotator via the network. And that's what we are going to do through Gpredict today. And now my computer is also connected to a ICOM 9100 so that we can actually do the Doppler shifting that's needed. Let me exit out of here and go and look at Gpredict a little bit. All right. Gpredict is a application which you can use to track satellites and as well as talk to them in the sense of getting data or tracking. Now coming up here, I have a SO50 pass. If I go to the next pass information, so here you'll see it's starting at 9:35, which is about 2 minutes from now. So I'm going to do a quick overview of what I'm going to try to display here. Well, short and sweet, essentially you can go into preferences in Gpredict to interface with different things. Now, for example, here I have the radio setup here to pre-control. And in order to complete that, I need to run any command on my computer. All right, so what this accomplishes is it connects through the radio and it gives you an interface that Gpredict can use. So that's all set up and that's ready to go. I can just forget about that. Now, as far as the rotators go, in order to set up a new rotator, what you need to do is to click on Add New. I'm going to say here is SatNogs, just give it a name. Now, for the IP here, we are going to use the IP of that SatNogs Raspberry Pi I mentioned. That's the IP on our network. And we are rotating, it's a 0 to 360 type rotator, but our rotator is also capable of going to 450. I'm going to change that. Then you can click on OK. Now, if everything works, it'll appear here. Now to test it, what you can do is you can go to antenna control. So that should pop up a window like this. For example, now I'm looking to talk to this satellite, so I can select that satellite. As you can see at this time, it's in view. Now, initially what I can do is I can click on engage, and that'll, if everything is working fine, it will read where your rotator, where your satellite rotator is pointing right now. And I am clicking on track. so that we want to track that. What happens when you do that is the circle is where it's intended to be, and the crosshair is where the rotor is actually now pointing. I'm looking outside to make sure that it's pointing at I think it is. I think everything's fine. Now, immediate some of the changes you might want to do here, set the threshold to about 2 degrees and update, let's say, 500 milliseconds, which seems to work reliably here. Okay, so that's my antenna rotator configured. Let me control the radio here. Okay, that's the radio controller. We need this window for now. It's tracking. Let me select the satellite here, and we want the VU repeater. Same thing. You get click on engage, and in theory, radio should. I'm going to change this really quick to see whether the radio is doing the changes as needed. It is, so everything is working fine. Contract. This will automatically engage the radio. Again, here changing this to 500 milliseconds, which is updating every 2 seconds, which is good enough. Now, to record this, I'm going to go to Audacity here. The ICOM 9100 has an audio interface that I can click on radio. Okay, something. No, just to double check it's here in the right thing. I'm going to use pulse video. On Windows, this might be a different application, but for recording. Okay, start recording here. Okay. All right, so this is actually working fine. It's using the radio. I can turn it down from the chat and see what happens. Okay. All right, headphones working. I'm going to switch the setup to headphones here to see whether I can hear stuff. Ooh. All right, let's see. So in this case, our rotator is right now, the south side of the sky is kind of covered. So once we get about 20 degrees of elevation, we should start hearing stuff. I'm barely hearing voices now.